Now that we have the chain rule at our disposal, we can really start differentiating more things, right? So something we've been sort of lacking at is being able to differentiate exponential functions. So we know that the derivative of e to the x is just e to the x, right? Using the chain rule, we can pretty easily figure out here that the derivative of e to the rx, where r is just a real number, is r e to the rx. Right? E to the x is the outside part, the rx is the inside part. So I'll let you verify that. So these two are going to give us a lot of ground, because the question we really want to ask is, how do we compute the derivative of b to the x? Okay. How do we compute that derivative? Well, like, a specific example of this would be, what's the derivative of 2 to the x? Right? This is what I mean. So here, b is your usual greater than 0, not equal to 1 kind of business. But anyway, how do we compute this? Well, we have to do some clever rearranging of b to the x. So bear with me on this. It's going to be a little bit of an adventure here. So we're going to start with y equals b to the x. Okay? And then what we're going to do is we're going to apply the logarithm to both sides. We talked about that in an earlier video. Okay. Now, the key thing here, remember that logarithms allow us to do, is to take this exponent and move it out front. So this gives us e to the y, or sorry, ln to the y, or ln of y is x times ln of b. Okay. Now what we're going to do is we're going to make both of these the exponent of e. So we're exponentiating both sides here. All right. But remember, there's a property, the property of logarithms. The main reason logarithms exist is to be an inverse of exponential functions, and e and ln are inverses of each other. So these cancel out, and the left side is just y again. The right side, well, we're kind of stuck with this. All right. So what we've done is we rewrote b to the x as e to the x ln of b. Now you might say, well, didn't you just make that worse? And you'd have a point. It kind of looks like that. But trust me, there's a reason for this. We know how to differentiate e to something. And so we're going to leverage that here. So the derivative of b to the x, all right, b to the x is equal to this, e to the x ln b. But we just talked about how to differentiate that, right? Derivative of e to the rx is just r e to the rx. This ln of b here, this is r. Ln of b is just a number. So when we differentiate it, the ln b comes out, and then we just get that same thing again. Right? But this e to the x ln b stuff looks bad. Let's get rid of it. Right, so let's switch it back. We get ln of b, b to the x. Right? And it looks a little funny in this order, so we usually write this in the opposite order. So let's just summarize that here. The derivative of b to the x is b to the x ln of b, right? So as a brief little example of this, the derivative of 5 to the x, for example, would be 5 to the x ln of 5. Right? So hopefully that makes sense. And now we can differentiate a whole bunch of more functions. We can differentiate exponential functions. So again, I'm just going to remind you, practice the chain rule. Take a whole bunch of derivatives with it and get used to it. Right? It'll be around for much time to come. Take care. See you in the next one.